quadrant, I don't want to spend very long doing this, so I'm going to go quickly. We got 30, 45, 60, do it on your own paper, pi 6, pi fourths, pi thirds. We got 1/2 square root 3 over 2, square root 2 over 2, square root 2 over 2, square root 3 over 2, 1/2. We know all that stuff. I also like to be a little cheater and put my tangents. Square root 3, square root 3 over 3, and 1. Now, if this all feels really good, did you see the questions that are coming up?
That's easy work.
Oh, yeah. Alright, these questions are not nearly as hard as they normally scare trig students into thinking. If we had a question that looked like this, that question I think exactly was on somebody's test. There was 2 versions, A and B, on the last test. And so the only thing new about this question is that it's also got a little bit extra. Okay, this is called trig expressions, which means it's going to have multiple little trig things that are then going to combine together. Now, 90% of the difficulty is your unit circle, recalling your unit circle. And honestly, we should be pretty good about that by now. And so the last 20% or 10% of the difficulty is like 4th grade math, arithmetic, and combining what's left. So, when I look at this question, 4, and what is the sine of 30? 1/2. And what is the cosine of 60? 1/2. And boom, trig is over. Time to go back to 4th grade, 5th grade, whatever it is, and combine this stuff together. We need to multiply 4 times 1/2 times 1/2. There's a bunch of different ways to do it. What happens if you start with 4 and you cut it in half?
2.
And you cut it in half again? 1 is the answer for the question. Woohoo! What I say? No homework. Oh, yay. Alright. You guys take it easy. You're being weird. Here we go. Now we've seen these before. Our favorite is the sine of 30 and the cosine of 60. Because it's 1/2. And our other options all have square roots. So at the start of this unit, I said my favorite thing to remember is that the sine of 30 is 1/2. Because when I do a question like this, I see the sine of 30 and I think, yes, that is my nice and easy 1/2. Then my cosine of 60 is also 1/2, and all of this is divided by 2. Here's how you want to do this. It's kind of like when you used to do like maybe this. Oh, you cannot use this gesture. I cannot use the eraser mode. All right, we cannot use the eraser. I don't really know what that means, but sure. Can't use the eraser, but good enough. Basically, I'm taking this sine and I'm swapping it out for a 1/2. This cosine, I'm swapping it out for a 1/2. And I recommend that you do a step 1 swap, step 2 solve. Don't do half of the swapping and half of the solving, because then you get lost in what did you already do and what did you not do. For this question, what is a 1/2 plus a 1/2? 1 or 2 halves, which is equal to 1. And when you take 1 and you cut it in half, the answer here would be 1/2. Where did that come from? 1/2 plus 1/2 is 1, and then you just have 1 divided by 2. 1 divided by 2. All right. Yeah. We're going quickly again. We're no homework, cruising at the end. Woo. Thank you. Somebody's paying attention. All right. So instead of swapping and simplifying, the 4, the 2, and the 3 are all important. Then the sine 300, cosine 30, I'm going to try to trade out for values. Now, not as nice. Right? We're not dealing with the sine of 30 and the cosine of 60 anymore. We have the cosine of 30, which is not the nice 1/2. It's the square root 3 over 2. And yucky, already not looking so good. the sine of 300, which family is the 300 in? It's in the 60 family. Ew. Also gross. And we're not in the first quadrant anymore. I heard somebody say negative because we're in the fourth quadrant for 300. Now what you need to get used to, a very common thing for these questions, because every angle, besides the quadrantals, every angle is giving you a fraction divided by 2. They like to match this with a coefficient that is an even number. So they balance out the 4 with the 2, and it kind of is your free ticket to getting rid of some fractions. Okay? So when I go to, we did our substitution, now let's do our simplification. I'm going to see that this second term here is a times 2 divided by 2. So this second term is just a square root 3. What would the first term be? 4 times negative 3 square root of 2 over 2. Don't worry about the square root of 3. Worry about the other stuff.
Negative 2 square root.
Nice job. Negative 2 square root of 3 over 3. And now we want to be a little bit careful about what we're allowed to combine and what we're not allowed to combine. These two terms, are we allowed to combine? Are they considered like terms? Looking at the top.
Yeah.
Yes, they are. This is negative 2 square roots of 3, and this is positive 1 square roots of 3. So if you're allowed to combine them together, it's kind of like negative 2x plus 1x, right? They just kind of work like variables would. And so what would our final answer for this question be? Negative 1 square root of 3 over 3. And these two 3's do not simplify, because one of them is inside of a radical, one of them is not. Alright, radians. Ew. Radians aren't that bad. Okay, pi 6, is that a...
How did we get that answer?
What is negative 2 plus 1? You're losing by 2 and you score a touchdown. You guys do everything by 6 and 7 points, whatever, that's weird. But you're losing by 2 goals and you score 1 goal, and now you're losing by 1 goal. Negative 1, square roots of 3. Nope, it's like negative 2, it's like negative 2 apples plus 1 apple is negative 1, but you still say apples. You don't get rid of that.
Oh, okay,
Because they kind of work like variables. Alright, here we go. Sine of pi 6 plus sine of pi thirds. Which one of these is a nice 1/2?
The last one.
The pi 6 is a nice 1/2. And this would be the other one, square root of 3 over 2. Now, as far as combining these goes, honestly, it's not awful the way it looks. Now, we probably, if we were going to final answer this, we probably would want to get rid of the parentheses because they're just a little busy. But what if it was a multiple choice? You might see the answer written differently from this. Do these have the same denominators already?
Yes.
Yes, so one way that you could also write this is like this, where you're just taking those two fractions. It's a 1 divided by 2, and it's a square root of 3 divided by 2. So just write it as 1 plus square root of 3, all of it divided by 2. That's, again, that is not trigonometry. That is 4th and 5th grade fractions. All right, one more question on the front. The sine of pi thirds plus the cosine of pi thirds. Well, we just did the sine of pi thirds, which was unfortunately the ugly one. The cosine of pi thirds, that's the nice one. Now these are squared and squared. So how do you square fractions? Multiply by itself, which basically means square the top and square the bottom. So what is the square root of 3 squared? 3 over 4 plus 1 squared. And what is 3/4 plus 1/4?
1.
4/4, which is 1. How weird is it that the sine of pi third squared plus the cosine of pi third squared equals 1? Pretty weird. That is actually the Pythagorean theorem. Sine squared plus cosine squared, x squared plus y squared. All right, that's notes.